this is a hexagon in SketchUp, and also another hexagon inside the other hexagon, and we can see through this that this length here, from here to here, visually looks smaller than this length. So if I take a measurement from here to here, you can see that that is 1 meter. You can see it down here in the lower right corner. And if I go here and take a measurement from here to here, and I can see that's 1 meter too. So the question is going to be, why do these different lengths have the same measurement? Well, the answer is going to be one of perspective. So you can see that I'm actually considering the blue will be a 3-dimensional, and the gray is actually a flat 2-dimensional hexagon. Let's turn it. So you can see now. Let me bring this up, down. I can scroll out. Okay. So we see that in fact the cube can be compressed or projected onto a 2-dimensional surface from a spot. If you had your eyeball here looking straight down, you can see that it flattens out and projects. So one could say that the 3D cube, when projected onto a 2D surface, is in fact a hexagon, or a hexagon is the shadow of a cube on a point like this. So actually, a matter of fact, it is the shadow. So if you had a light up there where your eyeball is, and you cast it, so the shadow of the cube, as a cube in this position, will make a shadow of a hexagon. And this leads to some more general thinking that the projection of one object to another object loses a dimension, you see. So we could say that a 3-dimensional object will cast a 2-dimensional shadow. And then one could ask, well, what kind of shadow would this hexagon cast if you had like a very flat 2-dimensional lamp? So let me see if I can give you an idea. So if I could do a flat lamp, something like this, let's say, here's a flat lamp. I think it's flat. You can't tell from this angle. So let's say this is a lamp, and we had a light beams are going in this direction. Let's see. Then the question would be, what kind of shadow would this flat surface? So it will cast a line that's the length. I don't want to be on. I want to be on the red. Yes. It will cast a line that's the length of this point and this point. So again, the casting of a lamp. By the way, this is like a lamp, and these are the beams. So the casting of this is a 2-dimensional lamp that's shooting light beams, and this is causing this to make a shadow. That shadow would be, of this 2-dimensional, will be just a line. So now we lost another dimension. We went from 2 to 1. See, there's only one line up and down. But here we have up and down, left and right, and then here we have the cube that's being cast, its shadow. So the question is, what kind of shadow would the what kind of object would cast a 3-dimensional object? Well, it would seem, with inductive reasoning, that we could say, hey, you know what? There must be a 4th dimension whose shadow casts this 3-dimensional item. And I think if you look at it somewhat like a hologram, where you have convergence into this cube from a larger cube, a 4-dimensional cube, then that gives you some idea how higher dimensions continue to cast shadows or projections and start losing a dimension on the way, or gaining on the way up. Okay, thanks.